Welcome to the second tutorial in this series. In this tutorial, we'll be going over how to use click detectors, proximity prompters, and how to properly detect player collisions using the touched event. We'll be doing this by going over three examples. In the first example, there is a wall that will fall over when you click a button. We will also change it so that the wall falls over when you hold a button. In the second example, we'll be going over a braking platform that when the player touches the platform falls to the ground. A third example with a minefield where if the player touches a mine, they will be damaged. And we'll be going over a more advanced example of the minefield where mines can be activated by push boxes. We will also be going over how to make custom client objects easily customizable. If you haven't noticed already, this tutorial is quite long. That is because I'm going to be going over pretty much every single line of code that I write so that you know exactly what each line of the script is doing. As the tutorials advance, I will be going less over individual lines of code that I write and more just broad chunks. And so the code won't be covered quite as extensively. Anyway, with that, let's get into our first example. For this first example, we'll be making a wall that falls when you click a button. Before we get into any scripting, I like to kind of just lay out what the client object is going to look like. So we're going to just make a quick wall right here. I'm going to build up wall segments that resemble like little cracks in the wall. So when the wall falls down, it falls in these little fragments. All right, now we have a wall. I'm going to quickly model a little button here on the side. All right, so now I've built a mock-up of what I want this to look like. I'm going to select these little wall segments right here, and I'm going to group them, and I'm going to name this model wall. And then this little button part right here that's going to be clicked, I'll select this and name it button. And then I'll group these two together, parent this to the client objects folder, and name this something appropriate, like falling wall. I don't recommend naming all your stuff just model because then you're going to quickly get unorganized, and that is a nightmare, believe me. So make sure you're always naming your models and such so you can stay organized. So now this is in the client objects folder. If you remember from our last tutorial, we need to add a bool value and name it client object. And we need to grab a module script and name it client object script. Okay, and one more thing before we start scripting, we need to go on this button. We need to add a click detector. The only thing you can really change in this is the cursor icon for when you hover over the button and how far away the player model is from the button that it will still work. So right now, the character can be 32 studs away and you can still click the button. We'll name this more like 15 so you can't click it from too far away. But this is about good. So this click detector will just stay on this button, and we can use events to link this up to our script. Now we get to the fun part, writing the script. So first of all, when I write scripts, I like to have the script on one side of the screen, and then I like to have the workspace on the other side of the screen. So if I just drag this tab out and move it to this side of the screen, as you can see, we can have the script on one side and the workspace on the other. So first thing I want to do is I want to define all of my objects here. So we have a button, a wall, and a click detector. And I want to have all of those stored in my script so I don't have to write the location of these out multiple times. So I'm going to start by saying local button equals script.parent.button. And I'm going to say local wall equals script.parent.wall. And then we're also going to want to define this click detector because we're going to use it to determine when the player clicks this button right here. So I'm going to say local button click detector equals script.parent.button dot click detector. Now I want to briefly mention my variable names here. They use camel case. That means the first word is going to be lowercase and the rest of them are going to be uppercase. That's generally a good idea when you're writing code, just to have this camel case thing. Notice how my variable, for some people might say this is kind of a long variable name. I disagree. I generally think the more descriptive a variable name is, the better. Obviously, you don't want your variable names to be like whole essays. That's not a good idea. But people might start to shorten their variable names down a bit. So they say, okay, instead of click detector, I can say local button CD, and that's obviously button click detector. Okay, that's fine. If someone's reading through your code, it might be a little bit more ambiguous about what CD is, and they might actually have to look at what it's defined as to be like, oh, CD is click detector. I think it's kind of dangerous to shorten your variable names down frequently. So if I start saying, okay, button click detector, instead of saying that, I can say BCD, shorten it all. This might be okay for short scripts, but once you have scripts where you have like 20, 30 variables, and if they're all shortened like this, you're going to have a hard time when you're reviewing your code knowing what this actually means. So I like using descriptive words, button click detector, especially for this tutorial. It's very nice readability. It takes maybe 2 or 3 seconds to write out the whole thing. And personally, I just think it looks nicer. When writing scripts, I like to divide my whole script into smaller processes. So this script is really doing 2 things. The first thing it's doing is detecting when this button is clicked. And the second thing it's doing is having this wall fall over. So I'm going to make a function here called local function break wall. And what this function is going to do is when it's called, it's going to break this wall right here. I'm going to write a little comment to myself so I can remember, especially again, as you write bigger and bigger stuff, that you write little comments like this to yourself so you can remember what your functions and what your code is going to do. Now we need to do this first part, which is detecting when this button is pressed. So we can do this by saying button click detector dot mouse click connect function. And this is an event. If you don't know what an event is, basically an event runs a function when something happens. So in this case, when the mouse is clicked, it is going to run the function right here between these 2 lines. And in this case, when the mouse is clicked, we want to run the function break wall. I think it's important when writing code that you periodically make sure that your code is working, because if you write a whole giant script and then there's lots of errors, it can sometimes be hard to tell where the errors are coming from. In this example, I'm going to test to make sure that this break wall function is actually going to happen when I click my mouse here. So I'm going to write in my break wall function, I'm going to say print the button was pressed. And if I click this button and this print statement comes up in the output, then I know the script is working just fine and that it will call this function when I press the button. So if I just press that here, we can see that when I press this button, it says the button was pressed. So that means our script is working just fine so far. As you can see, I press it multiple times, and this print statement keeps coming up. So now we have that working, let's focus on breaking this wall. So we need each part on this wall to be unanchored, and we can use a for loop to do this. So we're going to say for I, comma v in pairs, and we're going to say wall, get children, do. And then basically, if you don't know, wall get children is going to get each of these parts, and then in this loop, it's going to loop over each part, and then do a certain thing for each part. And when we're using a for loop like this, I like to name my variables. So I is going to be index, which we're not actually going to use in this. So I'm going to just put underscore as a placeholder because we're not going to use it in this script. So I is not used, and then v is going to be the part that we are looping through. So instead of v, I'm going to write wall part. For each of these wall parts, I'm going to say wall part dot anchored equals false, because right now they are set to anchored true. And so basically what happens now is when I run this breakwall function, it's going to unanchor each of these wall parts, and then the wall will be broken effectively. So we're just going to quickly run and make sure that works. So as you can see, when I push up against the wall normally, nothing happens because these are all anchored. They're not going to fall over. But then if I press the button, it all looks the same. But then when I walk into it, you can see the wall breaks. Now, this is all right, but if we were doing this in a tower, the player might not realize that the wall ever actually became unanchored, and they might become stuck. So I think it'd be nice if the wall part sort of shot out a little bit when this button was pressed, instead of just staying in place. So we're gonna update the script a little bit. Now, to make these parts sort of shoot out, we need to add a velocity to them. And there is a property in part called assembly linear velocity. And when we change this value to, let's say, like 100, 50, 40, and then we hit play here, and then we unanchor this, as you can see, it kind of just shoots out. That did it all on its own. And so what we need to do is go through each of these wall parts, and we need to randomly set this velocity to be something other than 0, and they'll sort of shoot out and fall down, and you can really see it fall down rather than just unanchoring. So if we go here and then we say wall part dot assembly linear velocity equals, and then we can't just say like 40 or like 50 because it's expecting a vector 3 value, and that is basically an x, y, and z coordinate. So how to do this is we say vector 3 dot new, and we could say like 100, 100, 100. That would look a little bit weird because they'd all fly in like the same direction. So we're actually going to make this a little bit more random by having each of these be a random value between like negative 100 and 100. So we're just going to say math.random negative 100, comma 100. And 100 is actually a bit big. I think like 50 would be a better number to use here. 50, comma 50. And this part might get kind of long, but we're going to do 3 different random values. And now it's going to set, now what this is going to do is it's going to set one wall part to have a random velocity in any direction, going anywhere from negative 50 to 50. And negative just means that it's going to be going backwards rather than forwards. It doesn't have a negative speed. That doesn't make sense. So this line of code might look long, but it's really doing something simple. We can also do the same thing for the angular velocity, which is basically the rotational speed. So instead of linear velocity, we just say angular velocity, and as you can see, that property is right down here. It does a similar thing, but again, it worries about rotation rather than velocity. So now, when we hit play, we come over here and we press the button, the whole wall sort of crumbles down. So this effect looks cool, but we've actually introduced a problem by doing this, because now every time you press the button, the parts are just going to fly around randomly. And that is not good, because then, well, it just looks really funny. It doesn't make a lot of sense. So one way we can solve this is by using debounces. Now, debounces are used all of the time in scripting. You can look through, and pretty much anything that has a touch interaction is going to have some sort of debounce. Basically, when the player presses this button, it's not going to let the player press it again. So we can do this very simply by saying local button was pressed, and we can say false, because at this point the button wasn't pressed. But once we have this button pressed, we can say button was pressed equals true. This won't do anything right now, but when this button click detector event happens, we say if button was pressed, then return end. Okay, so what is this mean? Well, basically, it's getting this button was pressed value, which is going to be false when the script first runs, but true after you've pressed the button. If you've already pressed the button, then it's going to return out of the event. It's going to return out of the function, and it won't run this code. That's what return does, basically. So this little if statement is saying if button was pressed, and you could also say equals equals true, but Lua is a nice language, so if you just leave this part out, it will automatically check if it being true. That's like the default for this. So if button was pressed, then get out of the function. Otherwise, run this code. And yeah, now when we hit play here, and we press the button, it'll break, but then we can press it as many times as we want. You can't hear it, but I am pressing it right now. And these walls aren't flying around randomly. So debounces might seem a little complicated. They're not too bad. They're just basically checks that the script uses to make sure that an event doesn't happen more times than you want it to. So this was probably a lot to take in, especially if you're new to scripting, because we went over a lot of things here. We went over variables, we went over debouncing, we went over functions, we went over events. So there's a lot of new concepts here, but you're going to be using these concepts a lot, and you'll have a lot of time to get familiar with them over the series. I hope this wasn't too complicated of an example for you. I know iteration can be kind of a mind-boggling thing. If you need more help with it, again, I have resources in the description for scripting. But there are some really cool stuff that you can make when you know how to do all this. So we have this first example done, and if you want to, as a finishing touch, we can make this wall the same color as the normal wall. So that way when we press the button, it's kind of more of a surprise when it opens. That's just up to whatever you're using this client object for. Again, there's a lot of freedom there. I'm going to change the color back so we can still see what the difference is. Anyway, that is our first example done. Now we're going to move on to the next example that should be a little bit more interesting. In the second example, we're going to go over how to make a braking platform, or I would still call it a falling platform, but that's already an object. It's that thing from TOIB, you know, the fall thing. Anyway, so this one isn't going to be a model, it's just going to be a singular part. So we're just going to make a 3x3 platform, like so. And we are going to parent this to the client objects folder, and then we don't need to make a model for this one. We can just put the client object value right into this part itself. And there's no pre-work we have to do. It's just because this object is only going to involve this singular part, so we can just add the module script and begin scripting. I'm going to divide up the screen again. We're going to do the formula we did last time where we're going to define all of our objects. In this case, it's just one object. I'm going to name it platform equals script.parent. So that's just going to be referring to the platform right here and no other objects, so we don't have to define anything else. And then we need to sort of break the process down into smaller steps. So when we touch this platform, it needs to fall, and then after a few seconds, it needs to respawn back up to the part where it was originally at. So I'm going to make two functions, say local function break platform. And in this, I'm just going to comment unanchor the platform. And the next one, we're going to make a function called respawn platform. And this is going to bring it back up to where it was originally at, and this will happen after a few seconds. So we have these two functions down. Now we're going to create the touch event. So to do this, we're going to say platform.touched connect function. And this event is going to run when the platform is touched by anything. The player, by an unanchored platform, and actually that's about it. So in this little event here, we are going to put the break platform event, and then in this touch event, we want to wait a second or two, so we're just going to represent the task.wait 1, and then so it's going to delay before it falls, task.wait 1, and then respawn. All right, so this is the basic layout of our touch event. And we're just going to make sure this all works. We're going to make it print fall, and then print respawn. So these events aren't going to actually make the platform fall and respawn yet, but we're going to know that they're triggering in the right spot. So when we play this, we should expect that when we touch this part, it's going to wait 1 second, and then it's going to say fall, and then it's going to wait another second, and then it's going to say respawn. So we do that, we touch it, and we see fall, and then we see respawn. And it actually triggered it twice because I have 2 feet. So when I touched it with both feet, it was actually 3. So if we look at all of the components of our character here, we can see that multiple things are touching it at the same time. It was probably the torso and the legs, if I had to guess. So this is going to actually be triggered a few times. To fix this, we can add a quick debounce. Like last time, we can say local can touch platform equals true, because you can touch it if it hasn't been touched yet. But once it's been touched, you're going to set that to false. And then after it's been respawned already, we're good. We can touch it again. And this way, if we just add a simple if not can touch platform, then return end. So what we added basically saying, okay, can you touch the platform? You originally can't touch the platform. Okay, you do the function, you can't touch the platform anymore. After it's been respawned, you can touch it again. This check right here is saying, okay, if you can't touch the platform, then we're not going to run this because, well, you're not allowed to touch it right now. You've already touched it. It's already doing its thing. So that way when we hit play here, and we touch it, it's only going to print 1 and 1 of each. And that's exactly what we want it to do. Okay, instead of printing fall and printing respawn, we're going to actually make it fall, and then we're going to make it respawn. So we're going to say break platform. We're going to say platform.anchored equals false. Okay, that's pretty simple. The respawn is a little bit more complicated because when the platform falls, we need to know exactly where to put the platform again. And to do this, we're going to track the platform C-frame, which is basically its position and orientation. So if we say local original platform C-frame equals platform.C-frame, and when this is run in the variable, it's going to get the current C-frame and it's going to store it in this variable. As the C-frame changes, this variable won't change because it's only being set to the platform C-frame when the script is starting to run. So when the game runs, this platform will be in its original spot. It will get the C-frame and it will be stored for later. So then when it falls, we can say in our respawn function, we can say platform.cframe equals original platform C-frame. And then we're going to anchor the platform again. So when we hit play here, and we jump on this, it should fall, and then be brought back up. Okay, it's working perfectly. And many scripters will look at this and say, oh, we're done. We've made the platform fall. When it touches, it falls, and we're good. We don't have to worry about anything else. This can cause a bit of issues if you just leave it with the touch event. Because remember, the touch event isn't just concerned with the player. It would trigger for push boxes. It would trigger for any physics object. So if we had, let's say, a push box from a higher section, it could knock over our platform, and there's a little delay before it falls. So the script would treat the push box just the same as the player. And this might be fine in most cases, but there might be an instance where you don't want the push box to trigger this. Like maybe you have a puzzle where you're supposed to push the push box onto the platform so you can jump on it and then not be affected by it falling. A bigger example I could think of would be a kill brick spinner. When this spinner would touch the platform here, it would treat it like a physics object, and it would just continually knock it over. So that would not be good. I'll admit, in most cases, you're probably not going to get into much trouble using just the touched event, but it's definitely going to be infuriating if your platform keeps falling and you don't know why, and it's because your touched event was not factoring in for just the player. So now what's nice about this touch function is it will give us the part that triggered it. So if we say hit, for example here, this hit is going to be the object that touched it. So if we say if game.players get player from character hit.parent, then so if we said something like this, if not game.players get player from character hit.parent, then return end, this is going to make sure that our player is being detected. Now, why did I just write here? This looks like a monstrosity. Well, to understand what I just wrote here, you kind of need to understand how the player model works. So we're going to spawn in a character really fast. So as you can see, this is an R6 character. This is not a real player, but it has all the same properties as a character would in-game. These parts of the player are directly parented to the character, we call it. So this is the character model, and all these are parented to the character model. And when a touch event happens, one of these things are touching the trigger part. So let's just say, so like when you're jumping here, you're jumping and you touch the part, your two legs are touching this right now, and those are going to be two different touch events. And how you can tell if it's the player is if you can say, okay, is the parent of this, so right here, hit.parent, is this a character model or is this not a character model? And you can tell if it's a character model by the get player from character function. Is the thing that is touching this platform the character part of the character model or part of something else? And if it's something else, then we return. Otherwise, we keep going. And as you can see now, and we use a push box, for example, ignore my character model right there. The push box won't trigger it, but I will. And this spinner right here will also not trigger it because none of these parts are even close to my character model. Or none of these parts are descendants, as we'd say, of my character model. Only I will be able to trigger this platform. Now, in previous versions of the JToolKit, you'd have to actually do more than just this. In older versions of the JToolKit, you'd also have to say, I'm going to say local PLR equals game.players.localPlayer. And local player is just the player that is currently playing, not the character, the player. And you'd have to use this function and say, okay, is this player and you have to modify the function to say this. You have to so if there's multiple people and this is our player, this is the player that the client object script is working for, but then some other player touches this part, the JToolKit used to still count this player as a correct collision, and a few years ago it was kind of a nightmare having to work with, just having to put this extra little parameter in there, because it's not something you might really think of, but it used to be kind of an issue of other player models triggering your client objects. So this used to be a thing that you had to do. With the current JTOH script, you don't have to do this anymore. You can exclude this extra player part, and this script will most likely work just fine. And that has to do with the new collision group script, which has the other players as a separate collision group, so it won't collide with the client object. Still, though, I would recommend, for stability's sake, I would still recommend having this little extra part. So just adding a little bit of a not equals game.players.localPlayer. It's kind of nice to have just in case collision groups fails, or just in case you're submitting to a fan game that doesn't have the new collision group script. I'd recommend having this little extra part here, but it's up to personal preference. As a final touch, you may change the surface to indicate that it's a separate client object, that this one falls. Okay, so our client object is done. One thing I want to mention about this, though, if you wanted to change the delays, let's say that I wanted to make it 5 seconds before the platform breaks, but then 2 seconds before it respawns. If I had a lot of these, and let's say I had like one that was longer here, and one that I wanted to, so this one would take longer to fall, and this one would take shorter to fall, and this one would, like, if I had a whole obby here, and I wanted each of these to fall at different times, it would be kind of a pain to go into each of their scripts and change all these values by hand. There's things we can do to make our client objects more easy to customize. So if we add a number value in here to our custom client object, and we name this value, let's say, fall delay, and then we have another one, and we name this respawn delay. And then we go into our script, and instead of having wait 5 or wait 2 or wait 3 or whatever, we use this number value right here. We say script dot parent dot fall delay dot value, and right here we say script dot parent dot respawn delay dot value. This will grab these values instead for the fall delay. So now we can very easily say, all right, I want this one, the fall delay, to be 3, and I want this one, the fall, and then the respawn delay to be 3, and then this one, I want the fall delay to be 5, and then this one, the respawn, to be 2. And then we put another one down, and this one I want it to fall immediately when you touch it, and then respawn after 2 seconds. And then if we play it here, we can see that this one should take 3 seconds to fall. 1, 2, 3, good. And this one should take 5 seconds to fall. 1, 2, 3, 4, 5, 6. That is 5 seconds. I'm just a fast counter. This one will fall immediately, though. So having this customability is really nice, especially if you're going to be duplicating your client object a lot and you want each of them to be different. It's also nice just for if someone's looking over your tower or your custom client objects to know what they can customize. So if I was to give this model to someone else and be like, hey, I made a cool braking platform, they could easily change things around without having to go into the script and manually change these numbers around. It's kind of a quality of life thing, and it's up to you on whether you want to do that. Anyway, that's an example of a braking platform. As you might have noticed, I've been going rather in depth in these examples. Obviously, if you go to write code like this and you know what you're doing, you can get this whole script out in like 2 minutes at most, like this whole thing. I'm just being very in depth, walking through my whole thought process while making these, so you can kind of understand a way to approach making custom client objects. I know I have quite a few examples of some current projects I'm working on of staying organized even when you have giant, long, hundreds of line scripts. So yeah, it's important to stay organized. I'm going to encourage that throughout my tutorials, and it just means I'm going a little bit slower through the content. Anyway, we're going to go on to our third example, which has to do with making a minefield. And now for our third example, you're going to make a minefield. So again, as with the other two, I'm going to lay these out before we make any scripts. So I'm just going to put some spheres here. And here we have a minefield. And, well, let's just say there's a reason that I'm giving you a scripting tutorial and not a modeling tutorial. So the whole idea is that when the player touches one of these, the mine will explode and the player will take a certain amount of damage. So we're just going to really quickly group all these mines together, put them in a folder, maybe, and put this folder in the client-sided objects folder. And then we're going to go in the folder, add a bool value, name the bool value client object. Done this a few times already. Should start to be building a habit here. We're going to name this folder, let's just say Minefield. All right. And now we're going to name all of these parts mine. And then we'll add in our module script. In the module script, client object script. And here we go. So we are going to, first of all, so this is going to be a different example from the other two in that we're not going to write any like local mine equals script dot parent dot mine. And we can't write it like this because this would only count for one of these mines, not all of them. So we're not going to do that. Just like last time, we're going to break up our process into smaller steps. So our main function we're going to have here is when a mine explodes. So we're going to say local function explode mine. Okay. And secondly, there's not just, unlike in the other two examples where we had one platform or one button, there's multiple ones of these mines that are going to use this function right here. So we're going to write mine as an argument into this function. So that way that when we explode a mine, we can put the mine itself as an argument so that when we say like mine explode, this isn't a real function, obviously, but we can know exactly what mine we're talking about. We're going to write a comment in this function to remind us what this does. It just explodes a mine. Perfect. Now, if you remember from our first example, when we had the wall that fell over, we loop through each of these parts and we unanchor them. We're going to loop through each of these mines, and we're going to apply a touch trigger event to them. So we're going to go for I, v in pairs, script.parent get children. And this is going to get all of the children in the minefield. We're going to rename these variables like we did last time. Instead of I, we're going to just leave that blank, and then we can say mine. Again, these variable names don't actually really matter, but it's just kind of reminding us we're looping through each of these mines and changing their properties. So first of all, since we're looping through all of the parts in this folder, we're going to also be hitting this client object and client object script. Now, we can't add a touch event to a script. That doesn't work. It can only be added to base parts. So we're going to say if not mine is a base part, then continue end. And continue works kind of like return does in a function in that it just stops the current execution and goes on to the next item in the table. This way we're skipping past the non-mines and only applying the event that we want to onto the mines here. Now, about what I said before about adding a touch event, it's simple. We just say mine.touched connect function. And just like last time, we want to make sure that what the mine is touching is a player. So we're going to track that on with the hit variable. We're going to say if not game.players, get player from character, hit dot parent, then return end. If the thing touching the mine isn't a player, we'll just skip past it because we don't want, we'll say, kill brick spinners or push boxes to be affected by this. We just want the player to be affected by this. Now we're going to write our explode mine function here. We don't have anything in our explode mine function right now. And we're going to write that in just a second. But really quickly, let's just make sure this function works. So we're going to have a print statement that says mine touched. And this way, when we play test in Studio, we can make sure that our function is working by touching all these mines. And as indeed, all of them, when we touch them, they say mine touched. So we know that they got looped through correctly. And just to make sure that it's only working for the player, we can grab our Rubik script over here, Rubik spinner, and it's not triggering the mine touched event at all. And as you can see, these mines are also not affected by push boxes. It's only affected when the player touches it. Okay, so now that we have the touch event working, we're going to actually make the thing that explodes the mine. So when the mine explodes, I'm going to write a few comments so we can know what's going on in this function. We want to damage the player, the mine to disappear, so we're going to destroy the mine, and we're also going to want to make an explosion effect. All right, so let's go through these first two because these are the main parts of the mine, because the explosion effect is kind of a cosmetic and we can worry about that later. So first of all, we want it to damage the player. So we can do this by first defining a player variable right up here. We can say local player equals game.players.localPlayer. As a reminder of my little rant earlier, this is going to get the local player of whoever's playing. So it's going to be this right here. Now, a player is not the same as a character. A character is an actual model in Workspace. A player is just the actual client that's connected. We can get the character by saying player.character. And then now right here we have a character model. And as you can see, it's going to look like this in the game. We have all these different things in the character model. And the thing we want to know to decrease the character's health is this humanoid object right here. As you can see, this humanoid tracks a bunch of things, such as the name of the player. And if we scroll down a bit, we can see that it tracks also the health of the player right here. So we want to decrease this health by a certain amount. So we can say player.character.humanoid.health. And then we can say minus equals, we'll just say 30. So 30 is the damage event. 30 is the damage amount for each of our mines. And minus equals is basically just saying, is basically going to take this value and decrease it by 30. We're going to want to destroy the mine mainly because if a bomb goes off in real life, the bomb doesn't stay. And also so that the touch event doesn't go off multiple times and do more damage than we intend. So doing that is pretty simple. We just say mine destroy. Oh, and one thing I forgot to add, as you can see when I wrote the explode mine function, I actually forgot to add the mine argument right here. So we're going to want to do that. Because again, the explode mine function needs the mine in order to know what to do. First, what this is going to do when we call this function is it's going to do an explosion effect, which I haven't written yet. Then it's going to decrease the health by 30, and it's going to destroy the mine. We're going to do a quick play test to make sure that we are indeed damaged and that the mine does indeed disappear. And it looks like that's working just right. As you can see, my health is going down, and if I touch too many, I die. There's a lot of ways you can do an explosion effect. I like to use Roblox's built-in explosion. And the Roblox's built-in explosion works kind of weird. Basically, you need to create an explosion object, and you need to, in the script, and you need to parent it to the workspace somewhere, and you need to set the explosion position to whatever part you want to look like it exploded. So it's nice to, even though we can't use this object specifically, it's nice to kind of look at its properties to know what we can change. So we have all these properties here. We're going to, in here, we're going to say local explosion equals instance.new explosion. This will just create one of these explosion objects. And then we can say explosion.position equals mine.position. And also, since this is just a cosmetic effect and we don't want the explosion object here to actually kill the player because we're already affecting the health in the script, we're going to say explosion.blast equals 0, because otherwise it will actually hurt the player more than we intend to. So we're not going to really worry about that. The rest of the properties, as you can see here, are about good, but this blast radius thing needs to be set to 0. Oh, and one more thing, we need to set the explosion parent to, it really doesn't matter as long as it's in workspace somewhere, but we're just going to say script.parent so that it can stay in the client object. It's generally good practice to keep all the stuff that you want to use in a client object in the same folder or model that you have the client object in. It creates, just helps you kind of stay more organized. What's nice about the explosion object is it will automatically destroy itself after the effect has gone off, so we don't have to worry about having the script destroy the object. It'll automatically destroy in the workspace. So as you can see now, if we touch it, there's a bit of an explosion effect, and then we also get hurt. And one more thing we can do is we can also add in a sound when the bomb goes off. So if we go over to our toolbox right here, we go audio, and then we search something like explosion. You can just grab one of these sounds. This one seems good. We'll add this one in. And then we'll rename this to something that we can easily access in the script. So we'll just name it explosion sound. And playing sounds in a script is very easy. You have to say script.explosion sound play, and then it will play an explosion sound when we hit a bomb. So if we just test that right now, as you can see, it plays an explosion sound. Maybe it's not the sound we want. We can definitely change it out later if we need to, but it will work for our little demonstration here. This part of the script is really cosmetic with just the explosion and the explosion sound. This is to just add sort of immersion, I guess, sort of realism in a way, even though it's a Lego game. We don't really need realism, but it's still just nice to have. So even if you don't have this all the way down, that's okay. This is the part of the script that really matters because it damages the player. And this is really the part of the script that matters for gameplay. And that is the end of our basic example for the minefield. Now we're going to do a bit more of an advanced example with the minefield. We're going to make it compatible with push boxes. So this isn't too difficult to add in functionality for. If we grab a push box really quick, all we need to do is modify this line of code right here. In our script, this line of code tests for if the object touching the mine is a player, then it will continue the function. If it isn't a player, then it will exit the function. All we need to do is say, if it isn't a player, and hit.name not equal to pushbox. So what does this modification in our script do? So it's going through basically two checks on this one line of code. One is testing for if the object touching the mine is part of the player model, and the other one is testing for if it's not a player model, if it is a push box instead. And if it's neither, then it's exiting the function. So now, as you can see, if we hit play here, we hit the push box against the mine, it will blow up just the same. However, we can take this one step further. As you can see in our current model of these mines, if I go up here with the push box, and then I push this push box onto a mine, it will still damage me even though I'm far away from these mines. We can fix this by adding a distance check on our health decrease. So if I say, I'm going to add a little comment here that says, if the player is close to a mine, then damage the player. Instead of just damaging the player no matter what, we need to check if they're actually close to a mine, and then if they are, we damage them. So how do we check if a mine is close to a player? Well, we need to compare their two positions and see if the character model is close to the mine. So we need to say if player.character, and we can't just say character.position because models in Roblox Studio don't have a position value. I mean, they do have one right here, but you can't really access it in a script, at least not easily. So it's better practice to say player.character dot, and then we need to pick one of these parts in here. It's good practice to use the humanoid root part whenever you're looking for player position or tracking any main player stats, if you will, because the humanoid root part kind of guides where the whole player model is going to be. The humanoid root part is really what the whole player is based around. And so it's a good one to use for an example like this. So if we just say player.character.humanoid root part dot position, then we can track basically the player's position because the root part is like right in the center of the player. So we need to compare the humanoid root part position to the mine's position. So we can say player.character.humanoid root part dot position. Then we can subtract the mine dot position. So this is going to return a vector. So this is going to return something like, I'm just going to put in the corner. This is going to return something like vector3 dot new, and then it's going to be something like -2, 5, or 3. Like it's going to be the difference between these two parts. And what's nice about vectors is we can actually convert this into a magnitude. Now I don't actually know what the magnitude of this vector is, but we're just going to pretend it's something like 5. And that's basically going to be how, if this vector was a single line, how far would that line go? Magnitude is a little bit difficult to describe, but one way you can think of this is if a vector is like directions in a car. If we have a car that goes 3 miles west and then 4 miles north, then it would have traveled 7 miles, but as the crow flies, the distance between the 2 points that it traveled, that's going to be 5 miles. So magnitude is sort of like the as the crow flies sort of example. In 3D, you could kind of see this as like these two balls. So this ball is at a certain point, and then the other ball is -2 on the x-axis, 5 on the y-axis, and then 2 on the z-axis away from this point. The closest distance between these two balls could be represented by this little rope right here, and this rope would be 5.74 studs. So the magnitude here would be 5.74. So this is actually going to be 5.774. Vectors are a little more complicated. Again, that's why we're doing this in the slightly more complicated example. But magnitude is basically going to give you the distance as a single number versus the distance as a vector 3. So we can take these two positions and we can just say dot magnitude. Let's say the player, if they're farther away than 10 studs from the mine, then they won't be damaged. So we're going to say if this distance is less than 10 studs, then damage the player. Otherwise, no damage will be done to the player because they're far enough from the mine exploding that they won't take damage. And that is the end of the tutorial. Now, one thing we're going to be doing from now on is we're going to have practice examples that you'll be working out on your own. For this tutorial, your task is to make the braking platform from example 2, where if you touch it, the platform falls over after a delay. But you will also need to script it so that when the player clicks this button right here, the platform will be re-raised and will not be re-raised automatically. So, good luck with that. If you need the solution, that is in the description below. And next tutorial, we'll be going over object movement and constraints. So stick around for that. Okay, bye.